Hey guys, let's take a minute to talk about kind of what we did yesterday with linear regression compared to what we're going to do today. So, yesterday we looked at kind of a sample problem from beginning to end, and we had to basically do everything by hand. We made a scatter plot of the data by hand so we could just see what the pattern or the trend might be in the data. Then we drew a line of fit. And again, that was our own line of fit where everybody's was a little bit different when I looked at the homework. And that's okay. There's nothing wrong with that. But then what we did was we used that trend line, that line of fit, to try to answer some questions. And that's okay. There's nothing wrong with that. But just understand that what we did was we found an approximate trend line of our own. And we did that just to see the trends in the data and to make different estimates of those answers. Okay, it was a very elementary way of looking at linear regression, and that's really important that we start with something like that just to get an idea of what the big picture is, what we can do when we analyze a set of data. Now, what we're going to do today is we're going to get a little bit more technical with this. We're going to use Desmos graphing calculator to do the linear regression for us. Okay, it's going to make the scatter plot for us. It's going to find the exact trend line, and I'll show you how to do that. It's also going to give us the equation of that trend line, so we don't have to try to guess what the slope and the y-intercept of the line are. And then when we're answering our questions today, we're actually going to use the regression equation or the equation for the trend line to find exact values and not just use the graph to eyeball it. Okay, so today is going to be much more about getting more technical and specific with our work. All right, we are actually going to look at the same two problems as we did yesterday. I should say the same two data sets that we looked at yesterday. But what we're going to do is we are going to use Desmos to do a lot of the work for us instead. All right, so here's our example from yesterday. This is the same data, but you'll notice the rest of the sheet looks a little bit different. I've included a lot of the step-by-step directions so that you can go back to it to help you complete the assignment. Just a reminder of the problem. My family's in the market for a new mid-sized car, but we decided we want to save some money, so we start looking at used cars instead. So the research is there with the age of the car compared to the car's value. And in terms of kind of going through these steps, the variables are still going to be the same, where we have the age of the car is your X, which is your independent variable. So age of car. And then the dependent variable, or Y, was the car's value. Okay, so nothing changes there. That's still the same. All right, in step 2, yesterday we made a scatter plot by hand. Instead, today we're going to make a scatter plot in Desmos. So just a reminder, the website desmos.com or desmos.com/calculator will get you right there. And what you want to do is you're going to enter your data into this area on the left-hand side. Now, to do that, the directions say, go to desmos.com/calculator, click the add item symbol on the left side and select table. Okay, so here's the add item. We select table, which is the third one down. It looks like a table of values. Now we have to enter our data into the table without any commas. It's important that you don't put any commas in here. If you use commas like 3,000, notice you get an error symbol right there. Okay, we don't want that. If you want to enter 3,000, enter it without commas. All right, so I want to use the age of the car as my X value. So a 1-year-old car was $29,000. Now I think if I just press tab again, it'll go straight down to the next row. So I like to keep using the tab button as I enter all of my data. All right, it's always a good idea to double check that you have your data entered correctly, because if you enter anything wrong here, the rest of your work is going to be off. So always, always, always take just a few seconds to double check your data. All right, looks good. Now you'll notice, and I'm going to zoom in here a little bit, make this bigger. I don't see my data. I don't see my scatter plot. So to do that, it says click on the magnify icon to the left of the table to view your scatter plot. Okay, so do you see over here, this is magnifying icon that's called zoom fit. When I click on that, it's going to zoom my graph area into those data points. Because again, these numbers are really big for Y values from 7,000 to 29,000, or even 6,000 to 29,000. So it's going to kind of change my graph appropriately. My X values appear to be counting by ones because, it went from 1 to 12. And my Y values appear to be counting by about probably 2,000 each line, 2,000, 4,000, 6,000, 8,000, 10,000, and so on. So that all the data fits nicely on the screen. Now, when we do this, we can see there is a definite trend, just like we did yesterday. We can tell it's a downward trend, meaning it's a negative correlation. And it's actually a pretty strong correlation here. All right. So we can do that just by entering our data into Desmos. We don't have to graph this on our own scatter plot. All right, so back to here. Number 3, describe the correlation. We decided that was a strong negative correlation. And for estimating an R value, I believe yesterday we said about negative 0.9. And that is an estimate. That is not an exact value. That is just us guessing based on the fact that we know it's negative, so that's to be a negative number. And because it's a strong correlation, it should be closer to -1 than it is to 0. Okay, so we pick a decimal value that's closer to -1.0. That's not exactly -1.0. All right, that's all we did there. Next step, we are going to get our trend line. Okay, so here's how we do that. Now, this is an interesting little equation, this little code that we need to type in. This is just something you either have to memorize or write down or always have access to it for your notes, because we need to type this highlighted equation into Desmos in the next spot. And it will only work after you've entered your data into a table. Okay, if you just open up a fresh graph and type this equation in, it's not going to do anything. It's probably going to give you an error message. But now we have our data in the table in Desmos. We are going to type that equation, and all we have to do is type these different characters. We don't have to worry about subscripts. Desmos will take care of that for us. Okay, so I'm going to just make this a little bit bigger so we can see that equation. So the first thing is Y sub 1. So I'm just going to press the Y button and then the number 1. And notice Desmos makes that lowercase, and then it tells us, oh, there's an 8-element list. That's because there's 8 items in this list up above underneath the Y1. The next thing is this little squiggle. I think it's called a tilde, but there's 2 ways you can get that. On your keyboard, it's next to the number 1. So hold down the shift key and press that button over there, and you'll get that symbol. The other way you can do that, because you guys can't see my keypad, is I believe, is this the symbols button? Nope, that's the pi button. Somewhere there it is. Okay, let me go back to that. I press the ABC button to get the letters, and then right down here, kind of below the B and the N, there is that same symbol that's going to give you that squiggle for your equation. So you can do that too. All right, next we're going to do mx1. So I just press mx1 and then end it with plus b. That's it. Type that exact equation into Desmos, and it's going to give us all the information here that we need. Okay. All right, so Desmos will display several pieces of information below that equation. That's what's here. So just a quick description of what those are. Under these statistics here, there's a r to the second power, or r squared, and then there's your regular r value. Okay, this is the actual r value, the correlation coefficient for our data. So it is, we were close, negative 0.9836. Okay, so it's actually a really strong correlation because that's really close to -1.0. All right, next we have M, which represents the slope of the trend line. That makes sense. We've been using M for slope a lot. And B is the y-intercept of the trend line. So what we're going to do is we're going to write our equation of the trend line using these numbers down here. And it's important that you use all of the digits in these numbers. Don't round these on your own. We want this to be exact. And I think I'm going to type this one in. All right, so we're thinking y equals mx plus b form. Okay, so y equals, now I want to put the value of m which was negative 2,081.84. Okay, then we have, remember, multiplied by x, so just put x. And then plus the b, the y-intercept, which was 30,739 and 9/10. All right, so there's my equation for the trend line. Make that just a little bit bigger and center it. Okay. So that is the equation for the trend line. Now notice when I look at my graph here, now that I have this in here, it gives me the actual trend line. Okay, that's not an estimate. That's not a best guess. That is the exact trend line equation. There's this big formula that goes into finding the y-intercept and the slope of that trend line. Okay, that's not an algebra 2 type of thing. That might be something you look at more in college if you end up studying something like this. Okay, so for us, we're going to use technology to get the slope and the y-intercept and use that to write our own equation. All right, so now we're kind of done with Desmos. I don't really need that anymore. So I'm going to make this bigger and, of course, zoom in. All right, question number 8. Oops, it should have been number 6. I forgot to renumber. We're going to use this equation of the trend line to answer these questions, the same questions we answered yesterday. So we said the sweet spot for buying a used car is 5 years because that's when the price comes down, but it still doesn't need many repairs. So how much money could Mr. Bennett expect to pay for a 5-year-old car? Well, if the car is 5 years old, that's the age of the car. And up above, we said the age of the car is the value of x in our equation. So I'm going to go ahead and take this equation and copy it. Here we go. And I'm now going to just replace the value of x, or excuse me, x with the value of 5. Okay, that's all I have to do right there is I'm showing my work in my equation, my trend line equation, and now I have to do a little bit of math. Well, for that, let's just go back to Desmos and use the calculator in Desmos. You guys remember Desmos is a regular calculator too? All right, so I'm just going to type this in. I don't know if I can copy and paste that. You know what? Let's try. Copy and paste. Hey, look at that. It works. All right, so I end up with $20,330.70 as my exact answer. Just remember that when you're giving your answer, that you put it in terms of, in this case, money, because we're talking about money. So we won't want to just say 0.7 at the end. We want to show that that's 70 cents. We don't want to round it because we want to give the exact answer because we're using the exact equation of the trend line. Okay. All right, and that is very close to what we said yesterday for a 5-year-old vehicle. And I can even look at my graph here. 5 years would be kind of right in the middle between 0 and 10. If I follow that up to my line, it does look like it should be right around $20,000. That's what we have. Okay, it's not an estimate, it's more exact. All right, second question. I found a 13-year-old car, wondering how much money I could expect to pay for this car based on the trend or the trend line. And let's see if I still have that equation. I did not. Copy. And paste. Okay, so this time I'm going to replace X, or the age of the car, with a 13-year-old vehicle. Okay, so replace it with 13 and go back to my Desmos calculator. And in Desmos, I don't need to retype everything. Let's just change the 5 to a 13. It automatically adjusts that answer for us. Perfect. So we have $3,675.98. Again, I don't want to round that. I'm going to make sure to leave it as exact as possible. because I'm using an equation that is pretty precise. All right, so $3,675.98. If you have a different method that you want to use or a different calculator you want to use to figure out what this equals, that's absolutely fine. I just prefer to use Desmos since I have it up, and it's easy to do a little copying and pasting for that. All right, nothing wrong since that's your work to copy and paste. All right, so a 13-year-old car. I think yesterday we said that would be about $3,500. And, one guy was asking $10,000 for a car that age. And we said, yeah, no, that wouldn't make much sense. All right, question 10. Deciding I'm on a budget, want to spend no more than $12,000 on a used car. Using your trend line, what age of a car could I expect to buy? Okay, now this one's a little bit different. I'm still going to use my equation for the trend line. Let me just do a quick copy and paste again. There we go. And in my equation, this time, I don't know the age of the car. Instead, I know the value, okay, the maximum value that I want to use of $12,000. So this time, I'm actually going to replace the Y with 12,000 because that variable, the Y variable, represented the car's value. And what we can do is we can solve this equation to get the age of the car. Make this a little bit bigger. There we go. All right, so to solve this equation, we think about how we solve equations. I have the kind of the middle of my equation there, and I want to start by subtracting 39.9 from both sides. And I bring this down, negative 2081.84x. And of course, this is a lot of decimals to be working with, so I wouldn't expect you to do this in your head. Grab your calculator. We have to do 12,000. Make sure to enter it correctly. Subtract 30,739.9. You get negative 18,739.9. Okay, so again, we're just solving an equation. Next step, if I want to undo multiplication, I divide. I know it's kind of annoying to have to write all these digits. And then we grab our calculator, do the hard part on the calculator. Divide, negative 18,739.9 divided by negative 2081.84. And I know it looks kind of funny here to have the negatives like that, but just know a negative divided by negative should result in a positive number, which is just bigger than 2, or excuse me, just bigger than 9, 9.00160435. So since X represents the age of the car, in this case, it's not going to make sense for me to say 9.00160435 years. I am going to round that one just to 9 because it is so close. So since X equals about 9, we're going to say 9 years. Okay, so that's the age of a car that I would expect to buy with $12,000. And that's using the exact equation from the trend line that we found using Desmos. All right, I would encourage you to maybe go back and watch this one more time, especially all those steps, because it can be a lot. And keep the video in mind while you're trying this on the homework too. All right, best of luck.